హలో సుధీర్
సార్
సుధీర్ సార్ లాగిన్ అయ్యారా?
ఇంకా లేదు సార్.
ఇంకా రాలేదా?
రాలేదు సార్.
ఒక్క నిమిషం కాల్ చేసి.
ఓకే సార్.
సుధీర్
సార్
2 minutes లో లాగిన్ అవుతున్నారు సార్.
ఓకే సార్.
నేను మాట్లాడాను.
ఓకే
గాయత్రి రెడీ కదా?
రెడీ సార్.
రెడీగా ఉన్నాను సార్. Sudhir, am I audible?
Yes, yes. Good afternoon, Raghukumar sir.
Yeah, good afternoon.
Sir, shall we start the session, sir?
Yeah.
Gayatri ma'am, please hand out the session now.
So, good afternoon, sir. Good afternoon to one and all. Myself, Gayatri Chittimoju, Assistant Professor in the Department of ECE, LIT, pledged to introduce today's resource person, Dr. J. Raghukumar Garu, who is an Associate Professor in the Department of Electronics and Communication Engineering at National Institute of Technology, Warangal. He completed his PhD in Signal Processing at AICTE Warangal. He completed his Master's in Electronic Instrumentation and Control Systems from JNTU, Kakinada. Completed his Bachelor's in Usmania University, Hyderabad. Dr. Raghukumar Garu has implemented 3 different DSD projects funded by Government of India and MHRD worth 36 lakhs each. Uh, his publications and workshops, he had 4 book chapter publications in Springer and published around 60 plus papers in various international journals and conferences like Elsewhere, Springer, SCI, Scoopers, and IEEE. One scholar completed his PhD, and presently 6 scholars are working under his supervision. Coming to his honors, he worked as an associate editor for 2 international journals, International Journal of Image Graphics and Signal Processing Hong Kong, and for Journal of VLSI Design Tools and Technology. He also acted as an advisory committee member for various national and international conferences. He chaired many sessions in IEEE conferences and also in 6th International Conference held at Swinburne University, Australia. He organized around 30 FDPs and workshops in various universities and colleges. His research interests include process control design, signal processing algorithms, nature-inspired algorithms. So now I request Dr. Raukumar Garu to start the session on K-means clustering algorithm for image compression. Thank you, sir.
Yes, thank you, madam, for a very nice introduction. So,
Thank you, sir.
so good afternoon, one and all. So I think this is which day? No, FDP started on. This FDP started on which date?
It is on 2nd, sir. Good afternoon, sir. I am Dr. Sridhar.
Yeah, fine. So this is 3rd day.
Yeah.
So it's 3rd day. Okay, sir. Yeah, fine.
It started on 2nd and lasts on 7th, sir.
Okay.
It is the 3rd day of the STTP, sir.
So by this time, probably you would have learned few algorithms. Okay. So,
Yeah, sir.
different. What are the algorithms covered, sir, so far?
So, in the first day, we had an introduction, sir, by Dr. Suresh Sundaram garu. And we have today we had session on support vector machines, SQL algebra, Bayesian theory, covered those things. Morning we had support vector machines.
Okay. So coming to machine learning algorithm. So by this time, you know what is machine learning, and then coming to classifications of machine learning, and you know supervised and unsupervised machine learning algorithm. So I'm going to
Reinforcement, all of this.
yeah, so I'm going to cover unsupervised learning. Okay, so one algorithm I'll take. So I'll clearly explain the algorithm, and then afterwards I'll be, taking care of, okay, so the applications of that particular algorithm for image color quantization or image compression, we can say. So basically, I will be covering this K-means clustering algorithm, which is comes under unsupervised learning. Okay, so linear regression and all, I think you would have done, and then you had a hands-on session for that particular thing. Okay, so now let me go ahead and then deal with this K-means clustering algorithm. So yeah, so now let me show you the first, what we are going to do, what is this image compression and all, and we will, okay, so now let me show you, now let me share my screen first. So can you see my screen now?
Yes, sir.
Okay. System is a little slow. Okay, so I'll just show you what is image compression. So as you know, image compression, now we reduce the size of an image. Okay, so which we can know. So if you reduce the size of the image, then with lesser bandwidth, you can transmit your image. So the thing which is happening in your WhatsApp messages, like they will take an image and then you transmit from one place to the another place. When you transfer the files, so the image compression happens. So which we can call it as, and if you see the image now, let me show the original image. Yeah, so this is an image. So can you see my screen? So this is what the original image, which is having 96,615 colors. Okay, so if I see the image, you can, if you see the image, then you can find there is, what we can say, summer vacation place, a guest house kind of thing in China. Right, so here, okay, so yeah, so here our objective is to reduce the size of this particular image. So now if you try to see the size of this image on the disk, so it is 159 KB. This file is of .png, PNG format, and 159 KB. So here the size of the image we have to reduce. Right, objective is that, and then so that the compressed image size can be reduced. So which we can call it as color quantization, reducing the number of colors. Okay, reducing the number of colors. So here if you try to see here in the image, here you can find 96,615 colors are there. So now I want to group, that means if I want to reduce the number of colors, I can see the image in a binary format. Okay, binary image, or we can say grayscale image. So in grayscale image, two colors only. Binary image means two colors only. So the entire thing you can convert into a black and white image. So when you say black and white image, all the pixels related to intensity of one will be grouped into one, another. So here I'll try to show you the demo. So if I reduce the colors to 64 colors, 16 colors and 2 colors, right? So the entire image. Okay, So then here, then how would be the size of the image would be changing is what I'll try to show you as. Okay, so yeah, so this is what the code. Once I explain the algorithm, I'll try to come back here. So the number of colors is the original. No, I want to make the number of colors to 64. Okay, so this China.jpg is an image which is of 156 KB. So now the total colors here in the original image, if you try to see, this is of 96,615. So the entire thing, I am grouping them into 64 colors. Okay, 64 colors. So now if I execute this, so just a second. Just a second, give me. So it is original.png. Yeah, so I'll try to show you the thing. So image compression, when you can do your image compression, so how the size of the file it is getting saved on, and then which algorithm we use to do particular thing. So give me a minute. So I'll be doing this. It's one-dimensional. Yeah. See here, this is what the thing. Yeah, now, so I'll just change the color to 64. So this is two colors, here the original image is this, which is of 96,615, and this is what just two colors. So if I save this image as binary, okay, of k-means, okay, so k-means, then this is what the executed program. So now if you try to see, so I'll try to show you the size of the compressed image. Okay, so here I saved it as binary k-means. So size of this, if you try to see, it is of 11 KB. See here, the binary k-means, this is what the file I saved. So the original is 150. So this is, so here the title is mentioned 64 colors, but it is two colors, right? So it is of two colors, and the size of this is on 11 KB, and the original image is of 159 KB. Okay, original image is of 159 KB. So from this, if you try to see, the entire colors of 96,615 colors has to be classified into two colors. So this is also called color quantization. Okay, color quantization. So image compression, which leads to image compression. So which algorithm, which machine learning algorithm we use to reduce the size of an image is what I'll try to discuss, and how it happens and all, I'll try to discuss it now. So now let me start with k-means clustering, and one more thing I can show you, right? So right, so here number of colors, right? So this is of two colors, and then the number of colors, it can be of 64 or 16. Okay, so that we can do, right? So now, so that's what if these of two colors, original image and all, which we have seen. So how it is happening and all, we will try to see with the help of an example. So now, now let us try to take, what is this k-means clustering is. So this k-means clustering, let us take with an example of cricket as an example. So here what you are going to do is, same way how image compression is happening, right? So here in a given data, you are given with a player with number of runs scored and then the number of wickets taken. So your data contains runs and wickets gained by the last 10 matches of a particular player. So now what you have to do is you have to cluster them. Here this is what you have to do. So wickets is what you are trying to plot on x-axis and runs on y-axis. So now if a particular player is is scoring more runs, and a few players they are taking more wickets, runs are less, okay, runs are less, and then and wickets taken are more. So now what you have to do is you have to group them. So those who scored more number of runs, you have to classify them into, okay, you have to classify them into here, those who have taken more number of wickets, they can classify them into bowlers. Okay, right. So this is what you have to do. Two means two category of classifications. Who runs more number of who scored more number of runs, and then who have taken more number of bowlers. So now you classify them into two categories. So he's a batsman. Okay, he's a batsman, and then he's bowler. Okay, so two categories is what you have to classify. Right, so then you are going to make them into two clusters. So how we are going to make the entire into two colors. In the same similar way, you can classify them into number of colors. For image compression, the total number of colors would be 96,000. So this 96,000 colors you are going to reduce into either it can be of 64 colors or 16 colors or two colors. Okay, two colors, right? So then same similar way here also, we'll take an example where the data given is having a player. Okay, we will be having an Excel sheet. So here player and the number of runs scored by them and number of wickets taken by them. So now you have to classify them by seeing this into two categories, bowlers and batsmen. Okay, who is bowler and who is batsman, into two colors. So how it happens and all. So now let us know which algorithm we use to classify this is what we'll try to take up now. So that is by using k-means clustering. Okay, k-means clustering, and then it will comes under unsupervised algorithm. Means no training is what required. So they themselves classified into different data. So now what you have to do is, here you have the data. Initially you have the data. Then what you can do is you can take two centroids. And that could be, randomly you can take two centroids. Right. So here one blue color is one centroid, and then orange color is what you can try to take another centroid. So the first step is this. You randomly assign. So that centroids are going to depend upon the number of categories you are going to classify. So, okay, number of categories. So how many clusters you want? Okay, so number of clusters here I want is 2. So then 2 centroids is what you have to randomly initialize. Okay, so then after that, you try to calculate Euclidean distance from all the points to the centroid. Okay, Euclidean distance to all the points from this particular centroid. Okay, right, that is step number 2. So in k-means clustering, what you do is, so initially randomly, initially you randomly initialize centroids. And step number 2, you calculate Euclidean distance. So calculate Euclidean distance. Okay, so you calculate Euclidean distance. That is step number 2. Right, then, right, from this centroid to each data point. Then now, similarly, similarly you calculate the distance of each point from this particular centroid. Okay, right, that is step number 2. Right, so then this data points, the data points which are having less number of Euclidean distance, you can categorize them into one cluster, and then the Euclidean distance, whose Euclidean distance is very close to the other centroid, can be grouped into one cluster. Okay, so that is in here. Right, so then that is how you just classify in the beginning. Then what you do, for the in one cluster, you actually calculate the centroid. Okay, actually you calculate the centroid. So that's what you try to say. So this is step number 2. Step number 3. So calculate Euclidean distance from each centroid to data points. Then step number 3, what you can do is update centroid. So how can you do? So this I will try to explain with the help of an example. Okay, don't worry. First you try to focus on what is the algorithm is, right? So then you update the centroid. Okay, so then now you can say no, and this process you repeat. So you repeat this process until the centroids are not getting changed. Okay, no further change in the centroids. And there you stop, and you can say, right, this, these players who scored more number of runs, so can be classified as batsmen, and those players who are taking more runs, then you can classify them into bowlers. This is in case of 2 clusters. Right, this is in case of 2 clusters. Right, so then, and yeah, so with highest wickets and lowest wickets, right. So this is comes under unsupervised learning. So and now we will go ahead with this, and this algorithm is widely used. Okay, this algorithm is widely used for different applications. So the same thing, like if you try to take Hyderabad city, okay, Hyderabad city. So the biggest vendor like Big Bazaar. Okay, Big Bazaar or Maison, where they have to locate their stores. So then here you can try to take an example. So Kukatpalli is somewhere here, Dilshuk is somewhere here, Uppal is somewhere here. Right. So, and Mehdipatnam is somewhere here. Okay, so Mehdipatnam. So right, so now they want to establish their stores. So where if they establish, then their profit will be more, right? So then their profit will be more. That is what the problem is. So this is one particular application. The second particular application is Ola cabs, right? Ola cabs, right? Where they have to locate their drivers, and upon the request of a particular user, so whom they have to assign, which driver they have to assign, so that he can go in a faster way and then get maximum profit. Right. So these are the applications. And third application is what? Image color quantization. So now there, if you try to see, this is particular the problem. So Walmart wants to open a chain of stores across. This is example available internet is what I have considered. Right. So then here, this problem can be solved like this. So initially, Big Bazaar or Walmart or they will be having people, the users who purchased from the stores. Right. So initially, now let us take the start with one center. There are 2 centers they want to establish. So one center is at Kukatpalli and one center is at Dilshuk. So where they have to start. So initially, the first step of randomly initialize the centroids. So one centroid you can establish at Kukatpalli, another center you can establish at Dilshuk. Now you will be having data. The moment you purchase any goods, then they will be taking your mobile phone. So by seeing your mobile phone and then your address where you are located at. So then from each user, right, from this particular center, they try to calculate the distance. Okay, so they will try to calculate the distance. Right. So if more number of users, if they are nearer to the Kukatpalli, right, so then they will group them into one. If those users are grouped into another one, and from here you try to calculate distance of each point from this particular thing. Right, and now lesser distance users they will be grouped into one. Right, so initially they will be formed into another cluster, and then they update the center that it would be Kukutpalli or somewhere here the place. Then again this process, it goes on iteratively, and less number of distance where the users are more, right, there they will find out one particular center and they will establish the center there, so their profit would be maximum. So now let us try to take now this in terms of steps. So here, how many number of clusters has to be formed can be known by the first step in K-means clustering is to fix the elbow point. So this, I'll try to discuss what is this elbow point is. The number of clusters which are going to be formed can be known by this elbow point. So once the elbow point or the number of clusters are fixed, you try to calculate, you measure the distance from each cluster, and then the next one is grouping. You group them, which are nearer to one particular cluster, you just group them. Then again you reposition of the centroids, and if the convergence has happened, means the centroids are not changed, then that particular point, right? So then here, there you have to stop. These are the number of steps in K-means clustering is. So now the important question is, how would you choose the optimum number of clusters? That we can say by using elbow point. So in elbow method, what you try to do is, you try to calculate sum of squares. Within sum of squares is what you try to calculate, which is defined as the sum of square distance between each member of the cluster and its centroid. It's very simple. So what you try to do is, number of clusters, how many number of clusters you have to point out, you can write it on x-axis, okay, x-axis, and within sum of squares you try to plot on y-axis, and within sum of squares you can calculate by using this particular formula, xi minus ci whole square, where xi is the data point and ci is the closest point to the centroid. So you try to calculate within sum of squares, and you try to plot number of clusters versus within sum of, if it is 1, then what is within sum of squares? Number of clusters, if it is 2, within sum of squares. Number of 3, then WSS. You try to calculate, and then here if you try to see this particular point where the error is, there is a drastic change in the within sum of squares. And after that, within sum of squares, there is no change in within sum of squares. There is no huge change. So this point, this look like elbow, your knee, right? Your knee. So at that point where the sum of squares, there is no huge change, those many clusters are enough, right? That is how you fix, right? So here in this case, when k is equal to 2, k is equal to 1 to 2, there is, within sum of squares, huge change, but after that there is no change. So this is how you fix the number of clusters, right? So once the number of clusters are given, then you try to do randomly, you initialize the clusters. So right, this is the same example of Big Bazaar or Walmart you can try to take. So one cluster is fixed here, another cluster is fixed here. Then you try to calculate the distance of each point and you group them. Okay, you group them. So based upon the distance from C1 and C2 centroids, if this distance is less, you group them into C1. If this distance is less, you group here. Similarly, when you try to compute the distances, if it is less, then you can compute into one particular cluster. So this is grouping. Then next one is reposition of the centroids. Then you update the centroid. Okay, then you update the centroid. Then then again you just go further. The same procedure, right? Convergence means the centroid point should not change. When it should not change, then again you measure the distance. Again you just group, right? So this we will try to use for image compression. So this is what the original color, original color, and then this is with the 16 color. Now if you try to see the quality of the image, okay, if you try to see the quality of the image, here you can see the same, but here original colors would be around 90,000 something so, but here if I reduce that into 16 colors, right, 16 colors, no information is getting lost. there is degradation in the quality, but here my objective is to find out what is there in the image. So if I try to see both the images, there is a flower inside, is what I can try to say, right? So here there are 16 million possible colors are there, and more number of colors means more size it occupies. Right, so this is what the original image look like, and this is what the 16 color image with 16 colors look like. Right, so here if you try to observe both, by seeing both, this would be occupying on the your this space 159 KB, but here it could be occupying 64 KB. If it is of two colors, I already executed the code and shown you, and it is taking around 11 KB. Okay, it is taking around 11 KB. So if you try to see both the images here, this is with 16 and this is with 96,000 something plus. Right. In both the cases, if you try to see, easily you can identify there is a resort, summer resort available, right, in both the images, but size is varying. So this is what we can try to say. We can use k-means clustering algorithm, and then we can reduce the number of colors. So how that can be formed is what we can try to see now. So now let me take an example. So k-means clustering algorithm means we randomly pick up k clusters. Right, C1, C2, C and so on. So that K cluster is decided by elbow points. I already discussed that. Then now you calculate the distance from each cluster centroid to the data point. Right, so lesson distance means you group them into one group and another, if it is nearer, then another group. Right, so this you try to form. Right, so now let us take this particular example. So I will try to see, give you one-dimensional data, two-dimensional data, and same thing how it can be applied for image processing is what I'll try to check up as. So now let us try to take, this is one-dimensional data. So in this group, there are, how many data points are there? 1, 2, 3, 4 means 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 numbers in this particular data group. So now I have to classify this data into 2 clusters. This is particular task. So now we will use k-means clustering algorithm. So what is the first step? The first step is how many number of clusters you are going to form. 2 clusters. Then you calculate, right? Then the second step is randomly initialize centroids. Right, so the minimum number is 2, maximum number is 30. Right, so 2 centroids is what initially I'm initializing. Okay, initializing randomly, randomly initializing. Right, so the first centroid is 4 and next centroid is 12. So first step, randomly initialize centroids. Done. Now what is the next step? You have to calculate Euclidean distance. Okay, there are the n number of ways you can calculate. So here in this case, Euclidean distance can be calculated by using this particular formula. U1 minus V1 whole square plus U2 minus V2 whole square, so on up to UQ minus VQ whole square. Right, so if you have one cluster U1, U2, so on up to UQ, and V1, V2, so on up to VQ, then Euclidean distance can be calculated by using this particular formula. Right, so now here, now the next step is to calculate the distance between this point and this point. Centroid, this point and this 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 centroid. Right? So when you try to calculate the distance, so 2 minus 4 is 2, right? And 3 minus 4, right? Square if you do, distance is 1. 4 minus 4, 0. and 10 minus 4, 6. Right, 10 minus 4, 6, 11 minus 4, 5. Right, so like that you can calculate the distances. So, right, 4 minus 30. Right, so there is 26. Distance is 26. Right, this is one thing. The next thing is 2 minus 12, 10, 3 minus 10. So 3 minus 12, 9, 2 minus 12, 10, yeah, 3 minus 12, 4 minus 12, 8. Right, then 10 minus 12, 2, 11 minus 12, distance is 1. So now, when 2 is the data point, it is compared with the centroid 4, distance calculated with 4 and distance calculated with 12. So this distance is 2 and this distance to this centroid is 10. So this 2 is grouped. So that is the Euclidean means here the distance is 2. So then it can be grouped into first cluster. Okay. So 4 minus 4, 0. So 4 minus 12, 8. So 4 belongs to first cluster. 11 minus 4, distance is 7. 11 minus 12, distance is 1. Right. So like that, this is classified into first cluster and this is classified into second cluster. Right. So this is step number 2. First number is initialize randomly the centroid. Second step is measure the distance or calculate the Euclidean distance. Step number 3, group them. Distance whose distance is minimum, that is what you group. Okay, right? Then third step. Now calculate actual centroid. So update the centroid is the next step. So 2 plus 3, 5, 5 plus 4, 9, 9 by 3, 4.5. Right. So here, sorry, 2 plus 3, 5, 5 plus 4, 9, 9 by 3, 3. So the centroid here is 3. And similarly, all the points by mean. So they just calculate the mean. 108 by 6. 1, 2, 3, 4, 5, 6. 6 points are there. So the centroid is 18. So now you update the centroid is what the next step. Right? Right. So this is what the centroid. Now again, you have to follow the same procedure. Now the current centroid is 3 and 18. Randomly when you initialized, it is 4 and 12. Right. So you updated the centroid. Okay. Right. Again, you have to repeat the same procedure. 2 minus 3, 1. So it belongs to first cluster. 3 minus 3, 0. 4 minus 3, 1. 10 minus 3. Right. 10 minus 3, distance is 7. 10 minus 18, distance is 8. So this belongs to which cluster? So 10 belongs to, distance is less. So that's why it belongs to first cluster. Okay, is this all right? Okay, so is this all right? Yeah. So like that, this is second iteration. That is what the first iteration, this is what the second iteration. Now the next step is, again you update the centroid. So when you try to compute the centroid, so here the centroid is 4.75 and the centroid is 19.6. Then again you group. Right, again you try to compare and then again you group. Just a second. These lines.
Sir, someone has annotated, sir.
Someone
has given annotated, so that's why they draw the lines, sir. So you can disable the annotate in the options, sir.
So I can do it
In Zoom, sir. Zoom.
Okay, so this is Zoom,
Yes, sir.
Yeah.
You can disable the participant annotation.
So here,
The topmost, you will find out the view options, sir. There you can see the more.
more.
Then you can see the annotation is allowed or disabled.
Disable participants and annotation.
Yes, sir. You can disable it, sir.
So I did.
Yes, sir. Now you can clear the annotation, sir. You have that power. I mean, you have that options.
So I can go now more.
Clear the annotations.
Where it is, where the option is. Annotate.
You'll find out annotate as separate, sir, not in the more. You'll find out annotate has an option there itself in the top.
So here I'm trying to do the same eraser.
Yes, sir.
Yeah.
Yes, sir. Right.
Sorry
for the inconvenience.
Yeah, fine. Thank you. So thanks for helping me out. Yeah. So yeah. So now, this is what these are the steps you have to follow, and again you have to calculate the centroid. So if you calculate the centroid here, the number of times you do, the centroid should not change. Up to that particular point, you have to repeat. Okay, right? Okay, so here again, if I try to go ahead. So here the centroid is 725. Then if I go further, now the centroid will not change. See, 2 plus 3, 5, 4, right, entire thing by the number of data points. So 725. So now again what I do, I try to compare each point to the distance of this, right, and then I'll try to compare. So here the distance will not change, right. So then I'll group them. So when I group them, here the centroid is 25, so it's very closer, and here this all belongs to one particular cluster, right? So now I can cluster them into two. No, I can group them into two clusters. This is cluster 1 and cluster 2. So all the given points here which we have taken. Right, here k is equal to 2, 3, 4, 10, 11, 12, 20, 25 and 30. So 2, 3, 4, 10, 11, 12 will belongs to one cluster, and 20, 25, 30 belongs to another cluster. Right, so this is how two clusters are formed. So now coming to the clustering, here you have hierarchical clustering and partial clustering. So this we are trying to discuss the k-means clustering, which is of partial clustering. Right, so here you have n number of ways of clustering, and you can go ahead, because this is not in a regular class to discuss all the things. So so here k-means clustering is what we are trying to discuss. So now if you try to put this into an algorithm, start input number of the clusters, calculate centroid, calculate distance, group based on the minimum distance, right, minimum distance. If centroid is not changed, again calculate distance, and right, and then group them. So this will goes on. And coming to the distances, here you can take Euclidean distance, Manhattan distance, squared Euclidean distance, cosine distance measure. Right, so these are available in the literature. We are using here Euclidean distance, right, which can be of as we discussed, sum of I is 1 to n qi minus pi whole square. Euclidean distance. This is squared Euclidean distance. And Manhattan distance, absolute value, by taking absolute value, right, and then cosine distance measure. and which one you have to go for means accuracy is what you try to compare, and then you can choose any one. So start elbow point, measure the distance, group based on minimum distance, reposition the centroid. Again, you have to go in a number of it. Now, if centroids is not changed, then you can. So is this clear up to this point? Any questions so far? You can ask me or you can stop. Is that k-means clustering algorithm is clear with respect to algorithm is clear, and I explained one example where the data points are given and where you are going to group them into one clusters. That is up to one-dimensional data points. Now, two-dimensional data points, if they are there, how to apply k-means algorithm is what I'll try to discuss now. So here we can stop, and then is there any doubts or any questions so far? You can ask me now. Now, any questions so far in the algorithm? K-means clustering algorithm, what it is. So this is what the flow chart. Right. If clusters are stable, then we can stop. If they are not stable, unstable in the sense what? Cluster centroid should not change. Right. This is what the algorithm we have seen. Now, how it can be applied for image processing is what we have to discuss. So, any questions, participants, up to this particular point? Is that k-means clustering algorithm is clear? And why it is unsupervised algorithm? Can you say now? Supervised, unsupervised.
There is one particular question from the participant, sir. If clustering is applicable for unstable video as an input or not?
Unstable video as an input or not? See, the algorithm which you run, what do you mean by unstable video? Yeah, let us discuss that in detail. What do you mean by unstable video? Means your camera is changing so that occlusions are taking place.
Like live videos.
Live videos only.
Yeah.
So live videos, see, there are, if intensity is not there, quality of video is different. And when camera is changed while recording, okay, while you are recording, if camera is changed, that results in occlusions. Right. So what do you mean by unstable video there? Objective is, see, objective is when you stream your video, you have to reduce the number of colors so that the faster way you can transmit. That is what the objective. Right? So unstable video means which scenario you are considering.
His question is answered, sir. That's why there is no more question from him.
Hello, sir.
Yeah.
Sir, how you calculate the number of colors in an image, sir?
Yeah. So how do you calculate the number of, so how many number of colors are there, I told?
96,000 some change, sir.
That
for the first
is for the image which I have shown.
Yes, sir.
Right. But there is one slide which I have particularly shown 16 million.
To power 14.
Yeah, see here. How many number of IO?
For 8 whole cubes.
16 million colors are there. Right. Here you see, this is what the command you can use. Plot pixel data Right. So there are 16 million, possible colors are there. See here, if you try to see, this is with respect to, this is, RGB. Right. This is green versus red. And then this is blue versus red. Okay. Then one more. Right. So finding out, you can try to, that you can do very, simply, simpler color, commands are there for doing number of colors. Right. So here the image which I have shown is having 96,000 plus colors. Okay. Right. So that is reduced into 16 colors or 16 by seeing its intensity values. Intensity value. See here, the first thing is green versus red color plot, and blue versus red color pixel intensity values. Okay, pixel intensity values. So here, if you try to see the number of colors available, right? So I'll come to that point. Okay. When I'm explaining, I'll come to this point a little later, right? So easily you can try to do. So is that all right? One-dimensional color, one-dimensional clustering is clear to everyone? Yeah, now image is of two-dimensional data. So if it is of two-dimensional data, how to cluster or how to group a pixel which is having same intensity level, right? That is what the thing we have to consider, so that we can reduce that into the number of colors. So now we will try to take the second example. So here the first thing is 2, 3. It's a two-dimensional data. So 2, 3 is one data point. 5, 6 is one more data point. 8, 7 is one more data point. 1, 4 is one more data point. 2, 2 is one more data point. 6, 7 is one more data point. 3, 4 is one more data point. 8, 6 is one more data point. So total, how many number of data points are there? 1, 2, 3, 4, 5, 6, 7, 8 data points are there. And now these 8 data points, we have to group them into 2 clusters, right? Into 2 clusters. So how can we do this? Now let us try to see. Same thing we consider, right? We consider, you convert your image, color image into grayscale image. Your pixel intensity values are 0 to 255, right? 0 to 255. So how many colors you want to see? Then you group them, right? So image is a two-dimensional data which you can represent that it's based on the number of colors, right? So the same thing you can, in this example suits for that particular case. So now first, here, what is the first step? So this is what the k-means algorithm. So what is the first step? Anyone? What is the first step you have to do?
Selecting centroid.
Yeah, randomly initialize centroids. That is the first step. So randomly I am choosing, this is centroid. Right. So this is centroid 1, this is centroid 2. Means in the given data points only, I am choosing 2 random points. It may not be first and second, that is your wish. Or you may choose your own centroids which falls in within the same range. So randomly I am choosing, this is the first data point, means this belongs to one cluster, this belongs to second cluster. Means randomly, sorry, not cluster. Randomly I'm initializing 2 centroids. So this is centroid 1, this is centroid 2. That is step number 1, randomly initialize centroids. What is the next step?
Finding the Euclidean distance.
Yeah, find the Euclidean distance. So you have to find the Euclidean distance from this point to each point, right? Right, this is step number 2. Similarly, this point with this point itself also you have to find the distance. Anyhow, that is 0. Right. So this entire data points, I have to classify them into 2 clusters is what given task. Right, 2 clusters. So that's why I have chosen 2 centroids. Right. Right. So that is the next step. So now let us try to do that. Okay. So x comma y, 2-dimensional. So x comma y. So if you try to take 2, 3, 5, 6, 8, 7, 1, 4, 2, 2, 6, 7, 3, 4, 8, 6. So given all data points, I'm just listing them in a table. And randomly I have chosen this is one centroid, this is another centroid. Right. Now, I'll try to compute the Euclidean distance now. So which is under root x minus 2 whole square plus y minus 3 whole square. Right. So here the centroid, you know, this is a guess. Randomly you can take any value. Okay, these are the initial guesses, or you can choose any point which is available in the given data set. So this is what calculation of Euclidean distance under root x minus 5 whole square plus y minus 6 whole square. So now you compute the distance from any point, this to this centroid, this to this centroid, this to this centroid, like that. From each point you compute Euclidean distance, right? So now if you try to see here, anyhow, this point to this point, the distance is 0, right? So then these data points belongs to one cluster. Means you can take, this is cluster 1, this is cluster 2. One centroid belongs to, right? So then yeah, sorry for the disturbance. Yeah, right. So now you compute the distance of this centroid and then this data point. So here the distance is, Euclidean distance is root 18, and here the distance is 0. So this belongs to cluster 2. Okay. And similarly, you compute the distance of this point to this centroid, and this point to this centroid. So here the distance is root 52, and here the distance is root 10. So this point belongs to which cluster? Cluster 2. Okay, right. So now what is the next step? Similarly, this you have to compute, right, the distance of this point to this centroid and this data point to this centroid. Then when you try to compute, this is like root 2 and root 20. So then 1 and 4 data point belongs to cluster 1 because the distance is small. This 1 and 4 belongs to cluster 1. Right. This 1 and 4 belongs to cluster 1. So here this point 6 and 4 belongs to cluster 2. Right. So this is what you have to compute the Euclidean distance, and where the distance is small, that's what you have to group them into that particular cluster is. So C1, so this point belongs to C1, this point belongs to C2, cluster 2, then cluster 1, cluster 1, cluster 2, cluster 1, cluster 2. This is step number 2. What is step number 3? Anyone? So that's why I spent more time there for explaining K means clustering. What is step number 3? The first step is, see here, keep this in mind. Start elbow point. Number of clusters are 2. So then randomly initialize number of centroids 2. Now measure the distance. And when you measure the distance, grouping them, you group them based on the minimum distance. Next, what is the next step?
Reposition.
Reposition the centroid. So now you have to do the repositioning of the centroids. So now here, if you try to take, right, so these points belongs to cluster 1. These points belong to cluster 2. List them. So these are cluster 1. So can you see my screen?
Yes, sir.
Yeah. So
Yes, sir.
2 and 3 belongs to first cluster. 1 and 4 belongs to first cluster. 2 and 2 belongs to first cluster. 3 and 4 belongs to first cluster. And 5 and 6 belongs to second cluster. 8 and 7 belongs to next cluster. 6 and belongs to second cluster. And then this is how you have to do. Right. Then the next step is update centroid. Okay, update centroid. So you have to, in first step, what you have done, randomly you have chosen few centroids. Now, actual centroid is what you have to compute. So any idea how to compute the actual centroid? Anyone? One-dimensional data point, I told you, like once you do different clusters, then you just average, you will take average value, no? Right, total number of, total plus, the number of data points. That's how you computed your actual centroid. Here, how to compute? Anyone? Just idea, just for, to make class interactive. Update centroid. So actual centroid should be computed. So actual centroid could be, so now if you try to take, this is x1, y1, x2, y2, x3, y3, x4, y4. Now, someone try.
Shall we take the distance between the centroids?
Update centroid. Actual centroid has to be computed, no?
Yes, sir.
So actual centroid means there are 4 data points here. Yeah, now let me give you an example how we did in one-dimensional data. This is one-dimensional data, no?
There we have taken the sum of the points by total number of points.
Correct. So that's how you got this 7, no?
Yes, sir.
That's how you got 25, no?
Yes,
20 plus 25 plus 30 by 3, no?
Yes, sir.
And here,
x1 plus x2 plus
that's it. x1 plus x2
x2 plus x3 plus x4, 4.
Oh, that's it. And y1 plus y2 plus y3 plus y4 by 4. So you take mean value. So mean of x comma y is the actual centroid. Right. So this is what you try to do. And then now you compute your centroid. So when you try to do it here for the given data points, so here you will get the first centroid is x1 plus x2 plus x3 plus x4, 2 comma 3.25. And next is 6.75 and 6.5. So here you can, for easier way, you can make it to 2 comma 3, and here you can make it to 7, 7, roughly. Yeah. So this is what the next step. So what is the next step?
Euclidean distance.
Now these are the new centroids for us. Now we have to repeat the process. So what you have to do now? The same process we repeat. So the new centroid is 2, 3.25 and 6.75, 6. Actual value you can try to take, or you can round it off nearer by. So now 2, 3 belongs to which cluster? So here you will try to compute the distance. Anyhow, here you will get 0 and 2, 3 you compute this. So what is the distance you get? So here the distance is 0.25 and here the distance is root. So this belongs to C1. 2, 3 belongs to cluster 1. And 5, 6 belongs to cluster 2. And 8, 7 belongs to cluster 2. So this is how you try to make them into clusters. So is there any change of previous clusters in this time? C1, C2, C2. So C1, 1, 2, 3, 4. 4 data points and 4 data points. Anyhow, here it freezes. So, it's not going to change. So 2, 3.25. Right. So here when you try to combine, this will belong to cluster 1 and cluster 2. So now here what you do? 1, 2, 3, 4, 5, 6, 7, 8. Now this is your X and then this is your Y. And now when you try to plot them, so here the first data point is 2, 3. So 2, 3. So 2, 3 is one data point. Right. And 5, 6. So 5, 6, this is one data point. So all the points you try to see, and then now here when you try to use your k-means clustering algorithm, here these points belongs to one cluster and these points belongs to one cluster is what you can find it out when you try to see this. 5, 6. 5, 6 belongs to a second cluster and 8, 7 belongs to second cluster, right? Okay, so the mean values you have computed and then you group them into one cluster and another cluster. Is this clear now how to apply k-means algorithm? So this is cluster 1, then this is cluster 2. So is this clear, all of you? Yes. How to apply k-means clustering algorithm for 2 data points?
Yes, sir.
Yes.
Yeah. Then now let us take this particular example to have a more clarity onto the concept. Now, what is the difference of previous problem and this problem? How many clusters we have to form here?
3 clusters.
How many data points are there?
8.
8 data points are there. So how it can be done? So now it takes just 5 minutes. So now let me discuss for 5 minutes. Because the colors, what I told you, the code which I have shown you, again I'll try to completely, I'll completely explain the code there. You will come to know this particular thing. Yeah. So now let us try to take. This is the first data point, second data point, third data point, 4th, 5th, 6th, 7th, and 8th. So now what you have to do? You have to group them into 3 clusters. So then what you do? These are your data points, right? So you have to classify them into 3 clusters. So you can choose any random data points, 2, 10, 5, 8, okay, and 1, 2. So 1, 2. So this is how randomly you have chosen the centroids. So now what you do, you compute this distance, and this distance. So this point where the distance is minimum, you group them that into that particular cluster. So when you try to compute the distance, so here this is one more kind of calculating the distance. This is not Euclidean distance. The absolute value is what you are trying to calculate. And I have shown you the different 4 types of distances. You can come Manhattan distance, sum of square distance, okay, so on, sine kind of thing, right? So now here when you try to compute, okay, so this is 0.1 and then this is 0.2, and when you compute, the distance here is 0, distance is here 5. So here this belongs to one cluster, okay. And similarly, you try to compute all the other distances, and now here the distance is 5, 6 and 4. So this belongs to third cluster, this belongs to first cluster, okay. So like that you classify them. Is the point is clear? Is this point is clear? Yeah. What is the next step? What is the next step?
Repositioning centroid.
Repositioning the centroid. Okay. So now this belongs to one cluster. So cluster 1, only one data point is there. Cluster 2, 1, 2, 3, 4, 5. So all these 5 data points belongs to second cluster. And this and this. So this belongs to third cluster. So this is cluster 1, cluster 2 and cluster 3. Now as you said, now we have to update the, so this is cluster 1, cluster 2 and cluster 3. Okay, right. Now here we have to compute the actual centroid. Anyhow, this is only one data point. So 2,10 itself is the new centroid. And here the centroid is 6,6. And the next one is the centroid is 1.5, 3.5. And with new thing 2,10, 6, 6, 1.5, 3. You update the centroid. And now you compute the distance from each point. Now you repeat the process. So here the distance is 0, so it belongs to first cluster. And now you compute this point to this point, this point to this point, this point to this point. So 5, 5, 2. So distance is 2, so it belongs to third cluster, right? And this belongs to second cluster. 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 This belongs to third cluster. Now you see 4, 9. So 4, 9 to 2, 10, the distance is 3. And 4, 9 to 6, 6, the distance is 5. 4, 9 to 1.5, 3.5, the distance is 8. So which cluster this is? First cluster. So now what is the change of the previous thing and this second iteration?
The second cluster is changed to first cluster.
Yeah, so the last point, the data point A8 point, so it changed. Earlier it was, which cluster it is? Second cluster. But now it got changed to first cluster. Okay, right. So now again you repeat the process. Now you compute the centroid. Right, you compute the centroid and then you go ahead with this. So now what is the change you can see? The data points are updated. So this is cluster number 1. And coming to the cluster number 2. So these points belongs to cluster number. So yeah, so these are belongs to cluster number 2. And this point and this point, they belongs to cluster number 3. So there is a change in when you update the mean, or when you update the centroid, then the points. So this here, the k-means clustering algorithm, when you try to see this entire steps, now you can try to refine here. So here the k-means clustering algorithm, when you try to see input number of clusters, calculate centroid, calculate distance, group them based on the distances, right? So here, if you try to see the steps here, yeah. So step number 1, step number 2, step number 3, okay, step number 4. This is what the algorithm is. K-means clustering algorithm. Pick k random points as cluster center called centroids. Assign each xi to nearest cluster by calculating its distance to each centroid. Step number 3, find new cluster center by taking the average of assigned points. Step number 4, repeat step number 2 and 3 until none of the cluster assignments change. This is step number 4. Such a simple algorithm this k-means clustering is. And here there is no training, right? The data points, they themselves change into different clusters. That's why it is called unsupervised learning algorithm. Unsupervised learning algorithm. Okay, so here if you try to see these 4 steps here for the example which we are considering now. Okay, so this is another one, right? So here if you try to see here, right, so cluster 1 and then cluster 2 and cluster 3. Yeah, this is, and after that, you have to do this process until your data points are not going to be changed. Centroids are not going to be changed, right? So now if you depict this on 2-dimensional thing. So here this is A1, A2, A3, A4, right? A4 and A1, A2, A3, A4, A5, A6, A7, right, and then A8. Total 8 data points are there. So the steps which we have seen, now if you try to see, right, so initially you assumed then a centroid. So in the first iteration, right, only one point is there so here in the first iteration, only one point is there in this cluster, right? But in the next iteration, when it goes on, right, so this changes, right? So the data points which distances are very nearer, then that you group them into next iterations, right? So this is how you group them into different clusters. So this is what the problem, the given data points, and then this is what the solution is, right? So grouped into 3 clusters. So the example which I have shown you here, image or color quantization, right? So the number of colors, if I try to take 16, save as image compression, 16 colors. Yeah, see here, this is what the original image, this is what the 16 color image. So this, if I save this here with the 16 colors, and if I try to see here by seeing this particular image, Yeah, 16 colors. What is the size you can see on the desktop? Yeah, anyone?
11 kb.
No. 16 colors.
Sorry, 63 kb.
63 kb.
63 kb. What was the original?
115.
159 kb.
So original is 159 kb. When I compress that into 16 colors, 63 kb is what I got. When it is of binary, I got 11 kb, na two colors. Right. So the same algorithm here, when it is of 16 colors, this is original, where it is 96,615 colors, and here it is 16 colors. And now, if I try to reduce this into 8 colors, this is with 8 colors. And now, if I save this image with 8 colors, and if I try to see what is the size,
39 kb.
39 kb.
39 kb. So image is getting compressed or not?
Yes, compressed.
Yeah, so this is called color quantization, reducing the number of colors. But is there any information loss? Now if you try to see, see here, this is with 8 colors. And this is with original color. In original color, you can see, right? You can see, in the image, there are few boats. Okay, in the back side there is water and few boats, and there is a port kind of thing. But if it is of 8 colors, can you see the background?
No.
And the posterization effects.
Yeah. So my objective is to find out what is there. My concentration is to see this particular, summer resort. Right. That's it. Now, if I change this to 4 colors. Okay. When I change this to 4 colors, can you see this now? Okay. This is for 4 colors. It means 4 clusters. I am grouping them. And now, if you try to see the size, what is the size?
24 kb.
24 kb. So my original is of 159 kb. This got reduced to, if I cluster them into 4 colors of RGB, each pixel intensity value RGB color image, if I try to take, and if I want not all the colors in that, I want only 4 colors, then the resultant image look like this. And binary image already have shown you, right, only 2 levels. Yeah. Still, if it is a binary image, I can see there is a summer resort available. Can I see any background information?
No, sir.
Absolutely nothing. Right. So edge detection. Okay. Right. So I can see 2 colors. I can find it out, and then I can go ahead with. So is this understood now? Is the algorithm is clear?
Yes, sir.
Clear, sir.
Shall we
Clear,
go?
clear.
Yeah. So now here, this is what 2-dimensional thing. And now if you try to see 3-dimensional case. This is one example. Right. Okay. So same principle, can I use it here? For color image compression, is the point is clear. The topic which I have chosen is K means clustering algorithm, which is a machine learning algorithm, unsupervised machine learning algorithm, and applied for image processing, color quantization. Right? So is this clear now?
Yes,
And
yes.
I got a paper long back. Okay, I got a paper. There are n number of research papers are available on this. Right? So let me show you my paper. So this is submitted by one of my student who is of just BTech second year and doing his internship. We wrote this paper and then presented at NIT Surat. Jaya algorithm based intelligent color reduction is what the title of the paper. You can find this in Springer. So we have taken k-means clustering algorithm. So for color quantization, there are two steps needed. Okay, there are two steps needed. Original image, pre-clustering and post-clustering. Right. So this pre-clustering is what we did with Jaya, one new algorithm. And post-clustering we did with k-means only. And the reduced image is having less number of, the lesser size, and the quality is compared with existing algorithms. Okay, by taking PSNR, pixel signal to noise ratio. So Lena image, Pepper, Manjul, Jet. So these are the database images. So when K is 8, this look like this. Clusters are 16, this look like this. 32, 64. This jet image you try to see, and colors are getting increased, the quality of the edges of the mountain. Right. So this is using only k-means algorithm. Pre-clustering and post-clustering, only k-means algorithm when you use, these are the results. And when we use this by using hybridizing of Jaya algorithm and k-means, both when we used the results, of number of colors when it is, and mean square value and PSNR value, we try to compare. Right. So k-means algorithm itself when it is used, and these are the PSNR values. And proposed algorithm 26.8. So PSNR got improved when K16 29, K32, right? So around different images. Okay, and then mean square values. Okay, getting less. So here pre-clustering and post-clustering, when it is done for the image processing, we used a new algorithm called, one new optimization algorithm called Jaya algorithm, and then we gave it for means. Means, see here, you have to supply the basic centroids in the beginning randomly. Instead of initializing randomly, I use some optimization algorithm there, and properly if I initialize the centroids, then the result is much better, is what we have seen in this particular algorithm. Okay, so now research or applying machine learning algorithms is not that much far away, right? So here you can see the literature, you can get few papers, and when concepts are when it is ready, and then you can modify the codes which are available. So now if you try to see k-means clustering algorithm and image segmentation, okay, color quantization, you will get, there are n number of papers available. Okay, image segmentation using k-means algorithm. This is one more application of the algorithm which we discussed. So this paper appeared in a very good journal in 2015. It's a Procedia Computer Science. It's one. Okay. And now, similarly, how we did the NIT Manipur. Okay, so this is a conference proceeding. Okay. Okay, and here color quantization. Yeah, codes are available. You can use, right? So there are n number of papers are there. This is one paper. This is in remote sensing image processing. This is Journal of Physics color quantization application. So some Chinese people, they have worked on it. Okay, so color quantization, how they have done. So how to calculate the Euclidean distance? Red color, green color, blue color of different images. Right, so they used k-means clustering algorithm. So this appeared in which year? 2019. Okay, aircraft, playground. Okay, so this, like this, you can solve real-time problems. Okay, using this. So is this understood now? Any questions I can take up for next 5 minutes? Is this clear? Like,
Sir, only one doubt I have is first we are going to calculate the random centroids, and later we are going to obtain the original centroids.
yeah.
And after that, we are going to apply the centroid values to the nearby pixels. That's it, right, sir?
Yeah. So each point from that actual centroid to each point distance you calculate, and you group them which cluster it belongs to.
Yes, sir. So while coming to the compression, the number of pixels which are going to change their colors, right, sir? So if we are considering 64 colors, the remaining 16 million, among the 16 million colors are neglected. Only 64 colors are considered.
Yeah.
So there, what actually happening is we are considering one centroid point which has some color value.
Yeah.
And the nearby colors which is nearby to that pixel point, we are estimating
dominant color,
yeah,
which one, yes. That's what you are going to be, keep it as it is. Otherwise, you are just going to neglect it.
Yes, sir. Okay. Fine, sir. Thank you.
Hello.
Yeah.
Sir, good afternoon, sir.
Good afternoon.
Sir, actually related to issue compression, actually k-means clustering algorithm, just I'm very beginner and I learned very much, sir, through you.
Okay, okay, sir. Thank you.
But relating to compression, one doubt I am having actually. So first original image you are showing as a PNG standard, right, sir? So
right.
that image is compressed.
Yeah.
So again, you are saving as a PNG standard. So PNG standard itself is having some compression standards.
Correct.
So we are using some compression standards. Again, we are saving as a PNG image.
Okay.
So then what about our compression techniques?
See, coming to the image format, you can take PNG or JPEG.
Okay, sir.
Okay, you can take. The standard itself is having its own advantages and disadvantages. Okay.
Okay.
Only the point which I want to highlight is, if I take the same image, okay, you can take JPEG image, no problem.
But I'm not talking about clustering or compression, sir.
Correct.
Actually, I'm relating to my question only compression.
Okay.
Straight away, if you are using suppose JPEG, JPEG is having some standards.
Correct.
While you are acquiring that image through your sensors, so JPEG is having some codec, so that it compresses that image. So original image is compressed and we can store or we can transmit.
Okay.
So that is the only the reason we are going for compression.
Correct.
But again, I'm taking that JPEG image. I'm doing my K-means clustering and everything compression algorithms. After completion of compression algorithms, again I'm saving my image as JPEG.
Okay.
So again saving as JPEG image. So what about my compression details?
I'm not exactly getting you. See,
sir, actually original image is JPEG.
You want to see the compression ratio?
If suppose actually, sir, original image, when I acquire original image directly,
correct.
So without using any JPEG, so that image, suppose it is having some 1 GB image.
Correct.
I used my compression standards. I reduce 1 GB image to 1 MB image.
Correct. Okay. Okay.
So then I can save with my standard. So that is actually image compression what I am feeling.
Okay.
But what actually we are considering directly from RGB image as a JPEG image. Already that 1 GB image is compressed by JPEG, and we are taking that compressed image, and we are doing our compression.
So you mean to say there is a conventional method in JPEG standard from 1 GB to 1 MB I mean compressed, and that 1 MB to again I can compress further.
Right, we are compressing 1 MB to further 1 KB suppose.
Okay.
But again while we are saving that image into JPEG, again it is considering that standard compression standards on our image.
Okay.
So then how can we say that my image is compressed through my algorithm?
Oh, see, okay. Do you know, means, do you have like, in JPEG, like 1 GB image when it is converted into 1 MB,
right?
What is the procedure you followed?
Actually, in JPEG we are using some TCT algorithm and quantization and everything. So finally we are getting our quantized.
So coming to the metrics. Now let us say coming to the metrics. When you try to do your compression, what is the figure of merit you use?
What is the figure of merit mean?
Yeah, you compressed an image.
Right.
Correct. Then what is the figure of merit, the quality of compression which you do? What is the figure of merit you use?
Yeah, generally we are using PSNR.
PSNR. Another one is compression ratio.
We can say that, but
right.
actually
So
we can say related to compression ratio. We can say that, sir.
Right. So now the same image you try to see the literature once. Okay. You try to you try to see the only thing is the point which I am highlighting or which I want to mention is K-means clustering algorithm is one unsupervised learning algorithm, which is a machine learning algorithm.
Okay, sir.
So that unsupervised algorithm, how we can apply this for color quantization?
Okay, sir. Sir, actually, I'm not any thing related to this K-means clustering and everything. My problem is only on the compression. Actually, just I'm asking my doubt.
Yeah. Then you do one thing, sir. You just go through the literature.
Yeah.
The same standard image like Lena or Bubble or
same thing.
Yeah, when they are used by using that particular JPEG standard and compressed.
Yeah.
What is the PSNR?
Okay.
And what is the PSNR when you get by using this K-means clustering? Just see the literature. You will come to know, right? You will come to know the quality.
Okay, sir. Okay. Actually, I'm looking for my research side. My research side, I'm doing image compression.
Now, sir, there are other ways also. Computational complexity.
Okay.
So when you use your JPEG standard and compress, what is the computational complexity taken for online video?
Okay.
Right. Okay. So you try to compare in both the ways. Which method has to be used? You just decide.
Okay, sir.
Yeah.
Okay, sir.
Fine. Right.
Okay. Thank you, sir.
Thank you. Any other questions?
Good evening, sir.
Good evening, madam.
When we stop the iteration?
Your centroid here in this, madam, when we start means when you keep on doing your iterations, your data point should not change its clusters, madam. See here, if you see this in the right figure, cluster 1, how many data points are there? So now let us take this is cluster 1 example. This is cluster 2, cluster 3. The data points, if you do going on iterations, these data points should not change.
Okay.
This should be 2, this should be 3, this should be 3 in next iteration.
Okay, thank you.
Yeah. So I sincerely or I humbly request all the participants in this 1 or 2 hours you are given to me. So I hope if you learned a little bit, so I'd be very happy. So I have shown you a few papers are also Indian literature. Our we have to add Indianness to the literature. Right. So I hope small things when you are trying to learn, right, that should be resultant, that can be a gap filling research or new point of expressing your ideas. But all of us we have to increase the Indianness to the literature. This is simple conference paper only. So Chinese people, they you can see here, right? So similarly, we hope participants from India, they can do literature, and then every day Indians will get into research and then do more research and all, and in our literature, our Indianness will improve. So a small, simpler concepts which we learn and then should result and then small new idea. In the beginning it will look like this only, but you slowly if you keep on thinking new ideas and all, you will come across. Okay, so I hope you practically, codes are available on an internet. The code which I have just shown you, right? So this code is available on an internet. Just you can practice this. Python, I think whether they are giving you complete things, all the algorithms in Python. Okay, so you just learn them, okay, and then try to practice, and then get good research papers which will help you for your promotions and which improves Indianness to the literature. So and so by that, the actual aim of sponsoring AICTE to develop faculty, faculty this kind of sponsoring this kind of faculty development programs, which results in good teaching communication, good teaching, and as well as good research. Right, that can be seen, and I hope if I added a little contribution, a small thing which can make you like, this simple, the algorithm is the machine learning algorithm, then I'm succeed. I feel like I succeeded in utilizing this. And then one more suggestion is, and every time now, if you see Telangana and Andhra, I think all computer science branches, they will be having AI and machine learning, data science, and all, where you can learn these algorithms, and then perfectly you can teach your students. So with that, I think if no more questions, then I stop my presentation here. Thank you very much for listening to me.
Good evening, sir. Myself, Dr. Sridhar, the coordinator of this program. Good evening, sir. Ravi Kumar, sir.
Yeah, good evening, sir.
Sir, on behalf of Lenny Institute of Engineering and Technology, as well as on behalf of the vast number of participants from various institutions around the country, and participants from different industries as well, and researchers. On behalf of all of them, I convey my heartful thanks to you, sir, for having spared your valuable time to enlighten all of us with your valuable lecture. And also, with your kind permission, sir, we have promised the participants that we're going to maintain a repository of all the PPTs of all these 6 days, and we are going to share them with the participants at the end of the STTP. So with your kind permission, if you permit us and allow us, we can share even this PPT if you can send it to us.
I think you can see it is entire thing is recorded, no?
Yes, sir.
Yeah, session is there, sir. Session is recorded.
Yeah, when session is recorded, when complete thing is available in video.
Okay.
Yeah, entire PPTs which I have shown is available in video, no?
Yeah. But it so happens, sir, on the first day, Dr. Suresh Sundaram, sir, and one more research person yesterday, in fact, they asked me not to share the recordings with the participants.
Achha.
So it doesn't matter, sir, if it is...
okay, sir. Yeah, fine. That's
share
up to you.
it to the participants.
No problem, sir. I will send. No problem, sir. Yeah, thank you.
And also, other than this, if you can share any relevant material that can be useful to the participants, we'll share that also to the participants. Right, sir?
Okay,
So, thank you once again, sir. Thank you very much.
So the feedback link will be shared in the WhatsApp group as there is some problem in the feedback. So I request participant to please submit your feedbacks in your WhatsApp groups. Please be touched in the WhatsApp group. Thank you. Sir, Sridhar sir, with this we can conclude it, sir.
Sudhir, 1 minute now. Just to the participants, I want to make a small note.
Yes.
Tomorrow we are having a session, morning session and evening session. Both the sessions are going to be handled by industry people. So it's going to be like a hands-off session. Initially, some introduction to the theory and the use of the tool. Later on, hands-on session will be there. So I guess both the sessions are tomorrow are going to be very interesting. And especially those who are really pursuing some research work, and those who are really, I've just observed the questions posed by many participants, more of practice-based, which can be resolved to the max extent in tomorrow's sessions. So I request all of the participants to involve yourself with more enthusiasm in the tomorrow's sessions as well. And could I also please request you to come forward with any more requirements, like if you want any particular topics to be addressed within these 3 days relevant to machine learning. I'll just definitely try to arrange lectures for those topics. So this I've been asking all the participants for the past 3 days. Even now also I'm asking, if you're having any doubts, any topics, if you really feel like got to be shared in this platform, kindly share those to me. I'll just try to arrange some clarification or lectures on those topics. And finally, I thanks all the participants for your patient listening. Let us all reassemble tomorrow morning by 9:50 a.m. Goodbye. Good luck to all of you. Sudhir, we can wind up the session.
Okay, sir. So once again,
And
I'm
the feedback link will be shared in the WhatsApp group. Kindly all of you submit your feedback responses. Right. Thank you.
It will be shared within an half an hour. You please be interact in the WhatsApp group so that it will be useful. Right. Thank you. So by this, I'll conclude the session.